Hello everyone, my name is Pedram and I'm a professor in data analytics. Welcome to another episode of Deep Learning. Alright, hello everyone, welcome to the module number 3. This is a Python part of our machine learning review. In the last video we covered the boosting algorithm, and now let's see how we can do them in PyCaret. So let's go to the deep learning course, the GitHub, and then go to lectures and codes, module 3. This is a file that we're working on, machine learning PyCaret classification. Now let me show you how we can open it. Imagine you install PyCaret on your local computer, so you can either open it locally or you can open it in Google Colab, right? So if I go to my GitHub folder, so this is a GitHub folder, hopefully you see something like this on your computer. Again, Deep Learning Spring 2023, you don't see these ones yet. No, I'm working on them, so don't worry. You see only these two. You see the PDFs and this one. You can open it locally or you can open it in Google Colab. So how do you do it in Google Colab? So simply, if you go to this IPy notebook itself, you should be able to go ahead and click on this Open in Colab. And it's going to open this one. Machine learning PyCaret classification in a Colab, right? So you have to go ahead and copy it to your own drive to make sure it is your version and you can work on it, right? So you can make edits, you can do whatever you want to that file, right? So this is your version. It's called copy of module 3 ML PyCaret classification, okay? If you decided to do it in Google Colab, it comes with a caveat, and the caveat is that you have to install the PyCaret package, which is, by the way, a very heavy package, every single time that you want to work with PyCaret, right? But the good thing is that you don't get into any hiccups if you want to install the latest version of PyCaret, and this is what we're going to do, right? So there's pros and cons. And the installation is not going to take more than, let's say, 5 minutes, depending on your connection, the server you have been dedicated, and things like that. But hopefully, you should have a seamless experience. So if you decided to do it in Google Colab, you have to make sure you run this cell, and it says, again, exclamation, pip install, -- pre PyCaret full. So you have to put this to make sure that the latest version is installed. And you have to put this bracket full to make sure that we have access to XGBoost, CatGBM, and lightGBM, Catboost and lightGBM. So these are the boosting algorithms that we're especially interested in, right? Especially based on what we covered last class. So I'm going to go ahead and hit run. This is going to take, let's say, 5 minutes, right? So this is going to run, well, it's connecting to the server, if you see that. And let me see. Once the process has been started, you will see something is going on. Okay, actually, I'm glad that you see this message. If you see this message, it's just, you have to type it again. Sometimes it doesn't like to, so I do pip install pre PyCaret and then full, and then go ahead and remove the previous line, right? Okay, it should work. Okay, now it's installing. Again, this process is going to take 5-ish minutes. So while it's working on it, I'm going to show you how to open it in your local computer, right? And let me go ahead and open an Anaconda prompt. Anaconda prompt shell. And here I have to make sure I go to the right directory. And so if you want to open it this way, right? So I can say, okay, hey, Jupyter, give me the kernel spec list. As you can see, I have two kernels. One is PyCaret 3 and one is Python. Guys, this is different from environment. If I say conda environment list, I have two environments. One environment is my base environment, which is Anaconda. The other one is PyCaret 3. And I happen to name the kernel exactly the same as my environments, right? So yours can be different, but again, you have to just give it a name to make sure that this is something different, right? Why do we care? Because now if I want to run things locally, I can say, first of all, let's activate that environment, conda activate PyCaret 3. And now in my PyCaret 3 environment, now if I do Jupyter Lab, it's going to go ahead and open a new browser for me. So this is the Jupyter Lab thing. And the kernel, which was important, it's going to load up in a second. You see, I have two kernels here, you know, PyCaret 3 and Python, right? So I can go ahead and say, you know what, this notebook of mine is I want to use the PyCaret kernel. Now, the PyCaret itself is automatically uploaded, so I don't need to install it every single time, okay? And so that was the second way to run it locally. The third way is, which I prefer, is to run it through basically your VS Code. You know, if you have VS Code, I'm going to show you how to do it, but if you have VS Code, you can run it on your VS Code. So I'm going to go ahead and double click on this file, you know, ML classification. And this is how the VS Code is going to look like, right? So this is what you see, okay? So again, either way, I assume that you have installed it either on Google Colab or on your local computer, but after all, you get here, okay? So if you have any question about installation, here's a link as well. And if you scroll to the end of this notebook, you see the documentation. So I want you to have this documentation. This is the latest version, 3.0. Have this open because I'm going to walk you through different, again, this is documentation. Let's go to the classification. The model, the functions that we use are all listed on the left-hand side. So if you want to know details about what's under the hood of these models, you have to make sure you read the documentation. So have this documentation open, have your VS Code open. Let me see actually the one that we were installing. Where is it? So it's still working on it. Okay, actually it's done. It was sooner than 5 minutes. Don't worry about this error. You can simply ignore it. And then now in our Google Colab, it seems that everything has been run smoothly. Let me go ahead and run this second cell to make sure that my PyCaret version is 3.0, okay? Okay, great. So if you get to this point, you're good to go. You can move on, okay? Again, I'm going to work on the VS Code because I already have it installed on my local computer, but you can go ahead and continue coding along with me using Google Colab. Okay, either way works. All right, so now let's go back to the first line. If you're on a local computer though, you do not need to run this line, okay? Just ignore this line because if you try to do it, it's try to install PyCaret again on your local computer. So skip this one. So that's why only if you want to run it in Google Colab, run this. Actually, let me go ahead and comment it out. Okay. You do not accidentally run it in your local computer. Okay, so now again, the version in my local computer, again 3.0, and now let's jump into a simple classification problem. What do? We're gonna, from PyCaret datasets, import get data. So this is actually, the reason that I do that because I want to work with one of the built-in datasets in PyCaret. Like any other machine learning package, PyCaret comes with some built-in dataset that you can play around with, right? So how can I get access to those? You can say get data and then simply do index. So here is the list of all datasets that you can play around with. Actually, this is a very useful place to play around with all these datasets. You don't need to be worried about, okay, where can I find time series dataset? Where can I find classification, multi-class classification, regression, and etc. So these are the different the different data sets that you can play with. You know, for example, binary classification. You can have multi-class classification. You can have clustering data. You can have NLP. You can have regression. In this class, we are doing classification, and the name of the data set we work with is called employee. So this is a data set with almost 15,000 observations and 10 attributes, 10 features, and there's no missing value. There's great news. So the variable of interest is left. So left means that if the employee left the work or not, so 0, 1, binary variable, right? So let's look into that data set. So I'm going to make a new data frame, call it data set. Get data, this is a function from the PyCaret, right? Because we already imported it, right? Get data employee. So here's my data set, and as you can see, it's let's quickly look at the information of the data. Again, 15,000 observations, and these are the variables, features: satisfaction level, last evaluation, number of projects, average monthly hours, time spent with the company, these are years, work accident, this is a dummy 0 or 1, to know if they had a work accident or not, because we want to see that if they left the company, was it because of an accident or not. Promotion within the last 5 years, yes or no. Department, there are 10 departments, sales, marketing, and you name it. And salary, 3 categorical variables, low, medium, high. And finally, we want to predict if they left the company or not. So hopefully the setup is clear. I can go ahead and see which one should be categorical, which one should be numerics. So I know that, for example, here we have these are the number of unique values, right? So this is I will be suspicious if the number of unique values is small, then I have to go ahead and see if they should be numerics or the categorical, right? So for example, number of projects, 6, this is totally fine. I can leave it as integer because it makes sense if I say if the number of projects goes from 1 to 2, right? What will happen to they leave the company or not? So this is, I leave it as integer. Time spent with the company, it's same story, 1 year, 2 years, 3 years. Work accident, this should be dummy, right? And promotion within the last 5 years, this should be dummy. Department should be dummy, and salary should be dummy. So I should have 1, 2, 3, 4 dummy variables, right? I can go ahead and define them separately and pass it to PyCaret, or I just see if PyCaret is catching them on its own or not, right? So let me go ahead. I'm going to show you either way. So because this is 15,000, I'm going to run it fast here. I'm going to work with a subsample of data, a subsample of 5,000. So I say, hey, dataset, work with a sample of 5,000, and the dataset, I just replace it with the old dataset. Okay, so this is my 5,000 observations. And now pay attention here what I'm doing. I'm saying that this is machine learning, right? So at the end of the day, PyCaret has this cool feature that you can make prediction on unseen data. So something that the model has absolutely never seen in the training part, right? So I'm going to say, go ahead and divide this data set into 90-10. This is different than train test split, guys. Pay attention. Say 90% of the data, I'm going to use it for modeling. 10% of the data, I'm going to use it for, let's say, for making predictions on the unseen data, right? So 90% of 5,000 is 4,500. So this 4,500 observation is used for modeling, and then 500 observation is used. This is the unseen data purely for prediction. Okay. So let's go ahead and run this cell. You should be, no, again, just it should be very straightforward how to do that. Just read through the code. Let me know if you have any questions. And now you should see something like this. This is our new data with 4,500 observations, right? Okay, and these are the columns. Okay, the next step is to setting up your PyCaret environment. So before you do anything, you have to set up your PyCaret environment. And what does that mean? It means that it initializes the training environment, right? So it does do the transformation, the pre-processing the data, everything automatically. So I'm going to go ahead and say from PyCaret classification, import everything. For your homework, you have to do from PyCaret regression, import everything. Okay, so that's it. And we're going to create a new experiment. I call it EXP, short for experiment. And this experiment is a classification experiment. So this is a class from PyCaret, classification experiment. Now I know that this is an object, this is an experiment, object saved as an EXP. And now I want to set up this experiment. Okay, I hope that it makes sense. This is Python, the programming language, right? Object oriented. So set up this experiment. I pass the data. I say that, okay, the target variable is left. Session ID, I just want to make sure that if there's a random process down the road, I get the same result every single time. So you can go ahead and change it. But if you change it, remember your numbers are going to be slightly different than mine. Now pay attention to this one, guys. So the train set is 80%. Remember, I have 4,500 observation, which was 90% of the data. Now I'm going to split this into 80 and 20. 80 is used for training the model, and 20 is used for validating the model, the tuning, the hyperparameters, and you name it, right? So I'm going in PyCaret, we call it holdout set. Okay. I'm going to go ahead and say pre-process is equal to true. So if you want to see what are the details of all these things, so here's where you should start. Go to the PyCaret documentation, setup. And as you can see, there is a lot you can change with this simple setup thing. So you have to do experiment.setup. And I highly encourage you to become familiar with PyCaret. It is worth your investment. It is worth your time. It doesn't matter if you spend 10 hours this week or next week on PyCaret. It is absolutely worth your time. It's so powerful. So for example, for setup, there are so many things you can do. You have to pass the data. You have to, for example, pass the target variable. You can say, this is my index. You can say, include these features, exclude those features. You can say, these are my numeric features. You can literally pass it to the model. So for example, if the PyCaret was not able to capture our 4 categorical features after the setup, I have to do it manually. I have to say, these are my categorical features, and it should be a list, okay? And again, read through the documentation. There's so many things, different types of transformation. So for example, you can do polynomial degree automatically added to the model, polynomial degree to the power of 3 added to the model. How you want to replace the missing variable. Do you want to remove the outliers? There are so many things that you can do in the setup, right? We want to keep it simple. So I go back and keep everything as default, just pre-process equal to true. Let's run it. Okay, so this should, because we only have 5,000 observations, it should not take that long. So it found 2 categorical features, but we were expecting 4, right? So remember, what do we have? We said our salary should be categorical, the department should be categorical, and PyCaret is only capturing these 2 because they were string in the data, right? So they were string, so automatically you say, okay, this should be category. But work accidents and if they got promotion last year or not is not detected as category. In this setup, it doesn't matter because remember, work accident and promotion within the last 5 years, they only have 2 categories. So they are already 0, 1. So it doesn't make any difference. But for your homework, if you need to specifically tell PyCaret, these are my categorical variables, you have to do something like this. So maybe after here, you can do something like categoricals. And then, now let me cheat a little bit and then do the, datasets, columns. I don't want to type them. So I have, what do we have? We have work accident, department, promotion, department. There was one thing I'm missing. Well, let me put these ones first. So these are my categoricals. And promotion last year, salary and left. Okay, salary should be there too. Salary and department, because left is already the target variable. So department and salary. So let me make sure I type it correctly. Okay, so these are my categoricals, right? And now you have your categoricals, you can go down and specify the categoricals. So categorical, as soon as you type it, it suggests you in VS Code or Jupyter Lab. In Google Colab, you have to do control space, right? After start typing. So categorical features, I just generated something called categoricals and then comma. Let's rerun this. Now you should see I have 4 categorical features. Okay. Again, for this exercise, it really doesn't matter because your classes were 0, 1, but you have multiple classes. You have to do it manually. This is your homework. You have to, so for your Logan housing, there are some categories that you have to set up manually. Okay, so now you know how to do that. So let's take a quick look. Guys, look at that. We had 4,500 observations. 3,600 of them is going to be train set, 900 of them is going to be validation set, right? Do you remember? So this is going to be used for cross-validation, for tuning hyperparameters. So 20% of 4,500 is 900 and the rest is train set. And we are keeping 10% of the total data set, which was 5,000, 10% of 5,500 for the end of this project. At the end of this project, we are saying what is the prediction of the model in the completely unseen data. As you can see in this process, I'm not touching those 500 observations. It's not part of the training. It's not part of the hyperparameter tuning. It's part of nothing. So that's why we like that 500 observations. We want to see the model. How does the model perform on that 500 observations? Okay, so again, the pre-process was true. It's going to go ahead and if there's any missing variable, it's going to replace it for you with mean. You can change all those things, right? And yeah, that's pretty much it. We are going to do stratified k-fold cross-validation. It's a k-fold cross-validation based on different groups. And then what else do you need? I think we're good to go. By default, the model used 10-fold cross-validation, but I'm going to show you how to change it. Okay. All right. So now Remember, every single function that you're going to call should come off of an experiment. So this experiment, I call it experiments. You can have multiple experiments. So you can say, this is my first experiment. I call it experiment 1, pre-process the data. I'm going to go ahead and generate another experiment 2, no pre-process the data, right? Then down the road, you can play around with those different experiments. So this is a cool feature that was added to PyCaret 3.0. What are the available models to you? Again, you have to do experiments.models and then to give you the list of models. So this is for classification under the hood. I think there are 18, if I'm not mistaken, you can count it. There are 18 models. For regression, there are 25 models. So it means that PyCaret is going to run behind the scene 18 or 20 or 20 plus models and compare all of them, do cross-validation, tune the parameters, do everything with maybe few lines of code. So this is why we like PyCaret when it comes to making fast predictions and maybe making benchmarks, and then use scikit-learn to dig down more, right? So what we covered in the past class was the boosting models, right? The XGBoost, lightGBM, Catboost, right? And if you have not installed the full version of PyCaret, you only see lightGBM. So if you want to see XGBoost and Catboost, you have to install the full version, right? So remember how we did that. We'd add the bracket full at the end of it. I think here we did this. If you don't do this, you will not see XGBoost. Okay, so let's go back to the file. Now we're gonna go ahead and compare models, guys. So let's go to the documentation. I'm gonna go back and forth, and this is what you should do while you're coding in PyCaret, back and forth between the documentation. So the next one is you can create models, you can compare models. Usually I start with compare models because I want to see, off the bat, what model is performing better among all the classification models. So for compare models, these are the inputs that you can give. You can say include only these models. If I don't put include, it's gonna include all the available models. I can say exclude only, for example, these models. Fold, what kind of cross-validation you want to use. By default, it's none, right? But I think we can, the cross-validation is true. Sorry, by default, the cross-validation is true. And the number of fold is equal to 10. So we can change them if you want. But yeah, let me see. I think by default, when you're doing cross-validation, the number of fold is 10. Just make it, yeah, and the number of top, let me actually show it in practice, it works better. So if you run this and do nothing, right, it's gonna go ahead and run, and as I said, it's 10-fold by default. It's using 10-fold cross-validation to report the model accuracy, AUC, recall, precision, F1, kappa, MCC, and this is just time it takes, right? And as you can see, it's comparing all these models, right? And at the end of the day, it tells you which one was the winner among all the classification models. So if you have taken machine learning, you do it in scikit-learn, we spend a semester to do it, we have one template for every single model, and now we're doing all of them in one line of code, right? So there's pros and cons in this, right? I don't want you to get addicted to using PyCaret for machine learning because it's not necessarily the best option, right? Because sometimes you want to tune the models. You want to make them a lot more customized. With PyCaret, there's some limitation, even though they're working on it, right? So for this data set, it seems that extra tree classifier, random forest decision trees, these are the winners, based on the accuracy, right? And where are our boosting methods? Catboost is here, XGBoost is here, and lightGBM surprisingly is here. So the reason that these boosting methods that we expect to perform well and they're not performing decently here, at least compared to a simple decision tree, is that our data set is small, right? Remember, I picked a subsample of 5,000. So if you work with 15,000, these boosting methods are going to perform better. And if you work with even larger data sets, these are going to be the winners. So that's what we discussed in the lecture video, right? But we're not going to do this, right? So this is for you to just give a sense that, okay, this project that I'm working on, which models should I pay more attention? So it seems that the decision tree based models are the winners, right? So now if I can somehow, tune them properly, maybe I get a good performance. So this is our agenda. So I'm going to go ahead and say, you know what? I have my own list of models. Again, this is something exactly like this you have to do for the homework. I'll give you this list and you have to apply it. So this is my model list. I say go ahead and use logistic regression. And if you're wondering what is LR stands for, this is logistic regression, right? These are the model tags. Decision trees, random forest, XGBoost, Catboost, lightGBM. So these are the ones that we discuss in detail, and these are the ones that basically decision tree based. And I'm going to use logistic regression as a benchmark, right? So I want to see, after all, whatever I do, can I beat my simple logistic regression as a benchmark or not? Now that you have your models, you can say, you know what, from that experience, compare these models only. Include only these models. It's a list. Number of select, it says that pick the top here to select the 6. I'm going to go ahead and save the top 6 performers in my models, right? Now I only have 1, 2, 3, 4, 5, 6. So it means that go ahead and select, save all of them, right? I'm going to need to use them later on. So among these 6 models, without doing any tuning or tuning hyperparameter, things like that, still it seems that using tenfold cross validation, it seems that, give it a second. Okay, it seems that our random forest is the best, decision tree is the next, Catboost, XGBM, logistic regression, and lightGBM. Okay, let's see if we can tune this, right? So guys, let's go back to the documentation. Compare models, we can tune models. So this is, again, read the documentation. This is your job. You know, if you want to do PyCaret in details, it's going to take hours, and this is not a PyCaret class, okay? I really want you to become familiar. Even though if you want more details, you know, I have another video on my YouTube channel that I do regression from 0 to hero. Maybe you can watch that one. And I'm planning to release some videos for time series in the following weeks as well. Okay, so let's go ahead and tune our model. So again, you can go look at the documentation. So what do I need for tuning the model? I need an estimator. And basically the estimator is a list of models that we have, and I can specify what is the fold, and automatically it's going to tune all the hyperparameters of all the models for me. Let's see how it's done. So remember, I'm going to look at my target variable, look at the value counts. The value count is relatively symmetric, relatively, okay? It's not unbalanced, it's relatively balanced. So when that's the case, I can use accuracy for tuning the hyperparameters. Because remember, you can tune the hyperparameters based on different performance metrics. Here, because the dataset is relatively okay or balanced, I'm going to go ahead and use accuracy. What do I have in my models? Remember, we saved 6 models in it. So this is the name of the models with all the parameters in it. And now I'm going to change them. I'm going to tune all these hyperparameters, right? So I'm going to say, use a list comprehension. From this experiment, tune model, each model optimize accuracy for all the models in my model. Hopefully this makes sense. We are going to tune a model separately down the road, but this should make sense. I have a list comprehension. Inside this list comprehension, remember, what is list comprehension? You know, I can say print x for x in range 5. So what does it do? It makes a list of 0, 1, 2, 3, 4, right? So what we're doing is basically say, okay, go ahead and tune this model using accuracy as the optimization. And for what? For the models in my model. Okay, hopefully it makes sense now. All right, so this is gonna take some time. We have 6 models, so let me go ahead and run it. And it's gonna do it in order. So sometimes if you do it in VS Code, sometimes some of the models don't show output. You have to run it again. So maybe this is not the best way to do it. In Google Colab, I think you will see that. But regardless, we're gonna tune all these things separately down the road, right? So again, this is my first model. The first model, remember, this is a list of the model. Let me actually, well, it's not gonna generate. So the list of the model, the first one is random forest, second one decision tree, third one Catboost, fourth one XGBoost, fifth one logistic regression, and sixth one was lightGBM. Okay, so this is our first one. We were able to, well, the tuned version of the decision of the random forest is 96. The accuracy is 96.89. Let's go back and actually see this one. It used to be 97. Actually, it got worse. The reason that it got worse is that, remember, guys, this is the cross-validation tuning process, right? So it means that we are going to do 10-fold, and each fold has got its own accuracy, and we're taking the average. So for random forest, well, the default values were okay, so we were not able to improve it. Decision tree, it was 94. Let's see what we get. The optimized is 96. Okay, decision trees was optimized. So the tune version is better. Catboost 92, XGBoost 88. So let's see. The third one is Catboost. Well, as I told you, yeah, well, it's working on it. So this is gonna take some time. And yeah, unfortunately, it didn't show me the Catboost. I'm glad you're seeing everything here. If you do it in Google Colab, probably you don't see this one. This is a VS Code thing. But I don't know if the Catboost was improved or not, but the next one was, we're going to do it separately. The next one was, let's remember these numbers. XGBoost 88, logistic regression 79, and lightGBM 73. Let's look at the XGBoost 88. So this is my XGBoost goes from 88 to 96. You see how sensitive it was to hyperparameters? So now XGBoost tuned version is going to be one of the winners, right? Logistic regression, not much improvement because there's no hyperparameter in logistic regression. And for lightGBM, again, I didn't get the output, but I'm going to do it separately. So the idea is that the tune model, I can look at my tune models. So now the parameters are different. The tune model are doing a decent job. So let's go ahead and create model and create those tune models separately, right? You don't need to, especially for large problems, you don't need to do this step. You can simply jump into the create model and then tune them manually. So let's do that. I'm gonna go ahead and create a random forest. I call it RF, create model RF. And I'm gonna make another model, tune random forest, call it experiments tune model random forest. This should be very straightforward, right? Now I have a random forest model with a tuned version of random forest model, right? So random forest 97, tune version. If you do it this way, especially if you're comparing many models, I highly encourage you to do it this way, right? You have a sense of what are the winners and then pick the winners and then tune them, right? Again, the random forest didn't improve that much, right? The next one is decision tree. We talked about it. Decision tree improved from 94.89 to 97-ish something, right? 96.61. Our Catboost, hopefully we are going to look at the tune Catboost output here. Sorry, it's taking longer than I expected, but as I said, this is worth your investment. This is worth your time. Okay, so this is your Catboost not tuned 92. Look at the tuned version now. Okay, it's working on it because the Catboost has so many hyperparameters. Catboost, XGBoost, lightGBM, they have so many hyperparameters, and you only have 5,000 observations, guys. Remember, so I think if you're doing it in Google Colab, it's going to take longer. So for the homework, I give you even a smaller data set, which is 2,000 or 1,000. But remember, if in the homework, your XGBoost, your beloved model is not the winning model, there is a reason, because the data number of observations is small. So you have to be very careful about that one. So the Catboost is usually the one that takes the longest when it comes to tuning hyperparameter. And I think we're almost there because I saw that the estimator was generated. Yeah, it's taking 1 minute on my machine. I have 32 RAM, and so probably on yours it's going to take longer. So Catboost, actually, look at that, the 92, 97. It's one of the best model now, right, after the tuning. So the winner, it seems that it's our tuned Catboost. You can go ahead and tune XGBoost and lightGBM, but I have done this, and it seems that the winner is our tuned Catboost. So I like this model. I'm going to do some plot with the tuned Catboost. The next thing, this is very powerful in PyCaret, is plot model. Again, from a specific experiment, plot this model. What do you want to plot? You have to first create that model. This DT that I write here, I can write it there because I created up there. I created somewhere here. If you don't create it, you cannot use that plot model, right? So you have to create the model first and then plot. I can see what are the parameters of my decision tree. Let's go back to the documentation quickly. Plot model. This is one of those things that you should really look at what we can do. So for example, in classification, we can look at the area under the curve. We can look at the threshold. We can look at confusion matrix, error, classification report, boundary. This is decision boundary, which is very nice. We can look at the learning curve, which we're going to do that. We can look at the feature importance, and etc., etc. So this is very powerful, right? This is what we can do. So let's go back. Imagine parameters. What are the parameters for my decision tree? it seems that for my decision tree, the parameters was criterion Gini, max depth none, the Bush history is available, max features none. I can go ahead and look at the parameters for the tuned model, what was different, because tuned decision tree, because we saw that the performance of the tuned model was better. So the tuned model actually, well, the criteria go from entropy to cross entropy, from Gini to entropy. The max depth went from none to 10. Max features went from none to 1. So as you can see, it seems that the tuned model performed better, and because of these are the parameters. We can do the same for Catboost, and this is our winner, right? Tuned Catboost. And as you can see, there are so many hyperparameters, right? And then we can go ahead and plot the AUC for our Catboost, tuned Catboost. So this is area under the curve, again, which is 97%, which is awesome for both classes, class 0 and 1. So this is great. And actually, it's very good. We know that 50% is right here. This is random classification, and the closer we are here, the better. So this is our 97% is excellent. We can look at the classification report for two classes, right? For example, in class 0, class 1, we have precision recall, F1 support. I assume that you know all these things, okay? So this is from machine learning. We can look at the decision boundary. This is another nice feature with the PyCaret. So decision boundary, if you want to do it in scikit-learn, which I did in my machine learning course, so I think we generated something like this in 20 lines of code, and now you can do it in 1 line. And basically, these are the blue ones on the blue background are correct classification, the green one on the green background are correct classification, and these are wrong misclassification. So these are misclassification here, these are the green one and the blue background are misclassification, right? And then we can look at the learning curve. So here's our learning curve. And if you remember from the machine learning the lecture video, which I reviewed, the learning curve, if the gap is wide, it means that the model is suffering from wide variance, and then you can get a better performance by increasing the data size. And this is exactly what's happening here. So this learning curve is screaming at me that if you increase the sample size, you should get a better performance, right? Again, this is going to take a little time, tune Catboost, but actually, this is good. You get some expectation on if you're running things locally or in Google Colab, how long should this take? Again, I have a 32 gigabyte memory, so it's a relatively powerful machine that I'm working on. So on your computer, it may take longer. Okay, so then while it's working on it, we can look at the feature importance, right? So plot model, plot the features for me. So it seems that the most important feature, if you want to leave the company or not, based on our Catboost model, turns out to be time spent with the company. This makes sense. And the least important one was if you were promoted within the last 5 years. This makes perfect sense, right? So the next one was satisfaction level, excellence. Next one, number of projects you work on, your department. These are basically in the same level. Last evaluation score, average monthly hours, and then the rest is relatively in the same order, okay? So again, the learning curve is taking some long time because, again, this is a tuned Catboost with so many hyperparameters. And remember what the learning curve is doing under the hood. It's increasing the sample size in the train set and calculate the performance both in the train set and the cross-validation with 10-fold. All right, so let's assume that it's done. It's going to take some time. We'll walk you through the rest and then I'll come back. So then your last step is to make predictions, right? So I'm going to say use the predict model. I think it's wrong. Yeah, here you go. This is our learning curve. And as you can see, the gaps start large and it's still large. So this is screaming at me that this data needs more observations. Remember, we had 4,500 observations for training the model. Off of that, we use 80% of that, right? So 3,600, I believe. So again, train set score, cross-validation score. And the score is accuracy. We hope that they converge to each other and then be something around 95, a decent number. But the problem is that they are not converging. So this means that I need more observations. Okay. All right. So again, the last step is your predict model. So let's quickly look at the predict model. predict model. Again, here's the documentation. This is a decent documentation. PyCaret is one of those packages that I really like the documentation. It gives you an example. You can go ahead and these are replicable. You can copy and paste this entire thing in a cell. It should run. You know, if you copy the entire thing in a new Google Colab notebook, it should run. Okay. And so what do? We say, okay, we have a model. The model's name is tuned Catboost. So we're going to say, use this model for making prediction. If I don't pass any other thing here, by default, it's going to make prediction for the holdout period. So remember, what was the holdout period? That, in this example, 20% of the 90% of the data, right? So we call it holdout holdout data set for just validation and cross-validation, right? So I'm going to run this. In the holdout set, the performance of the tuned Catboost is 97%, which is excellent, right? Then I can look at the predictions themselves, right? So what were the predictions for the holdout data set? So look at that, the prediction label and prediction score. Remember, guys, the Catboost is generating some probabilities. So you can say the first this guy, observation number 3600, with these features, there's 97% probability that he leave the company. And yeah, and the prediction label is 0. Well, actually, it's doing it the other way around. It's, well, yeah, prediction label is 0 and left. This is showing you the confidence level, right? So 97%, this is what they call a prediction is score. This is not probability. Okay, so we are 97% sure that this prediction is correct, and it was correct. So let's see if we can find a misclassification. So far we don't, because again the performance was 97%. I'm not going to find many misclassifications here, but for the ones that were correctly classified, we have a high prediction score. Okay, all of them almost greater than 90%. Excellent. Once you did the prediction in the holdout set, now it's time to finalize the model. So what does finalizing the model mean? Finalizing the model means that this is the model that you like. You want to finalize it. You want to finalize it on the entire data set that you kept for modeling. Remember, I had 5,000 observations. 4,500 of it I used for just building the model. So I'm going to train it on that, not on the training set, which was 80% of that 4,500. Okay, so maybe pause the video, do the numbers, make sure you're following. I have 5,000. Let me actually write it down. I have 5,000 total observations, right? Well, 5,000 total observations, and out of that, 4,500 was used for modeling, and out of this, 500 of them, well, 20%, 900 of them is holdout, and then the rest, 3,600, is train set. And the rest of it, which is 500, is unseen data. What we're doing here is, so remember guys, we trained the model on this, we tuned the model on this, now we're finalizing the model on this. Hopefully it makes sense. Okay. Now, so the model has been finalized on the 4,500 observations in this example. I can look at the pipeline of the model. So it's, again, this is Catboost. I can look at the pipeline. The pipeline basically tells you what happened under the hood, right? So we did some transformation. It seems that we didn't use any transformation. We used simple imputer. If there's missing variables, and etc. This is the way that the model handled categoricals, ordinals, one-hot encoding if it was done. And so that's a pipeline, right? This is your Catboost classifier at the end of the day. Okay, now I'm going to use this final model to make prediction on the completely unseen data. Okay, so that's the end of it. So that's why we say, okay, go ahead and use the same function. Remember, predict model. But I'm going to specify the model. If I do not specify the model, by default, it's going to make prediction for the holdout set. But when I specify this data unseen, the 500 observation, it's going to make predictions for these are unseen predictions. Remember, these are different than holdout predictions. So these were holdout predictions. These are unseen predictions. Okay. Again, in the unseen data set, it's doing a decent job with the accuracy of 98.4%. Actually, this is surprisingly very powerful, right? So your Catboost model did an excellent job in this employee classification problem. You're happy with that. You're super satisfied with the performance on the unseen data. There's no data leakage here, hopefully, because we didn't overkill the cross-validation. So it was just tenfold cross-validation. And now we're done. When you're happy with your model, go ahead and save it. So let me show you something. This is a folder. And while you're doing Catboost and etc., automatically it's going to make this folder on your computer, and there's a log. You can go ahead and delete them afterward. But I want to show you something. So here, if I go ahead and save my final model, I'm going to save it as my PyCaret classifier. Let's go ahead and do that. Okay, go back to the folder. It's a pickle file, right? My PyCaret classifier. Now, from now on, I don't need to tune this model anymore. I can go ahead and load it. And when I load it, all the parameters are going to be loaded with that, right? So I'm going to say, imagine you have this, your PyCaret classifier, it has been tuned. You spend hours on tuning this model. You save the winner. When I say that you save the winner, it means that you save the weights. You save everything, the hyperparameters and everything inside that model, right? You don't need to run all those things again. Then you're going to say, you know what? I have this picket file somewhere. I can get access to my winning model. I'm going to call it my winning classifier. You can call it anything. Now, this is my winning classifier. My winning classifier is basically a Catboost classifier, and I can use it now. Okay, so hopefully it was helpful, and that's everything you need to know from PyCaret classification in a nutshell. Until the next one, take care.